Video of 6.2. Excited to kind of put a cap on this one here. I'm going to go over a problem where we're trying to find the minimum and maximum values for a middle percent. In this case, we're looking at 60 percentile. All right. So where this comes into perspective is, let's say that I am a candy or a chocolate bar owner, and I'm like, I really want to kind of stay with the pack in the middle. I don't really want to be a high calorie candy bar or a really low calorie candy bar. I'm just kind of want to be in the pack of the middle 60%. All right, so if I were doing that, I'd say, well, I want to find the minimum values and the maximum calorie that I want to stay within, or like kind of like the parameters. All right, so let's break this down. I want to make sure that we all understand that if we're talking about this middle bar right here, we know that it's symmetric on both sides, and if we're talking about the probability, it falls right in the middle. So if we have 0 as a z-score, just to recall this little paper right here, if we have 0 as a z-score, it's 0.5. That's because it is right in the middle, all right? Right in the middle. So if you get a z-score of 0, it's 0.5. And that's important with this particular problem we're going to be looking at, because we want the middle. If I draw the minimum down there and I draw the maximum, this is definitely not drawn to scale, just drawing the two different sides, is I want this middle 60% right in there, right? So I want it to, and maybe you can see the writing on the wall here. It means I want 0.3 on this side, or 30% on this side, and I want 0.3 on this side, okay? So that's how we get those numbers here. Also written as 30%, but I'm using this because it more has context to our normal table that I have. So we're trying to find this middle 60%, in which I'll break up 30% on one side of the middle and 30% on the other side, okay? So I'm gonna erase this real quick just to not confuse you. This 0.5 in the middle becomes important because I have to figure out, well, how does this relate to my chart that I have here, okay? So we have to think that, okay, so this side is 0.5, 50% of the data. So what does that make this, right? I want to figure out, well, what do I have to look up in my z-table to find out what this is? Well, that would be 0.2, right? Okay, so if I want to find the value that is associated with this mark right here, I would look up 0.2 in my table. And maybe you're seeing the writing on the wall here, I would be looking up 0.8 here because I want to find the area. I'm concerned about finding the value that produces this spot right here, and that's 0.8. This is 0.2. Okay, so now I'm going to switch it up into two different problems here. Okay, so I got the 0.2. I'm going to go to my my z-table here, and I'm going to try to find out what z-score, I'm going to transfer this into a z-score, would produce 0.2 as the probability. So I'm going to go here, I'm going to try to find the closest thing to 0.2, getting close, getting close, getting close, and I notice right here 0.2005 and 0.977. Okay, so negative 0.8, and I believe it's 4 there. So 0.84, so this is the closest thing to 20, or 0.2, and so I'm going to use negative 0.84. So if I want to put that percentage into a z-score, that would be negative, or the 0.2 that's associated with the z-score, 0.84, okay? And then I'll go through the same process I just did. I'm going to say, all right, what value, I'll put this into black again, x minus, again, I'll go up here to the z-score formula right here. What value minus 225 over 10 would give me a z-score of negative 0.84? And then I'll go through that process. But let's try this one. So maybe try this one on your own and see if you can come up with this transformation or this particular formula. Because once you come up with this, it's kind of like just doing a little bit of algebra. So see if you can come up with this value here. All right, hopefully you took a little bit of time and try to figure it out. Let's see, 0.8, if I go to my z-score, or my standard normal distribution chart, 0.8, and this is not a coincidence. If you'll notice that the closest thing to 0.8 is 0.84, and that's not a coincidence that they have the same side, because if you understand that the distance the z-score is, it's equal on both sides. So if it's negative 0.84 on this side, it's 0.84 on this side. All right, So all we got left to do is a little bit of algebra here to find those maximum minimums. So we got 10 equals 0.84. And to speed up a little bit of time here, I'm going to just do the math. I've already kind of get the math done. So the x value that produces this is 216.6. And on this one is x equals 233.4. So going back to that analogy I explained in the beginning, is if I was a chocolate bar owner and I didn't really want to heighten the too much of the market by making a high calorie candy bar or a low calorie candy bar. I just want to stay right in that middle 60%. I would want to create a candy bar that has a minimum of 216 calories and a maximum of 233.4 calories. All right. So hopefully this kind of concludes our practice with 6.2. I appreciate your guys' time and working through these applications. I certainly will be available during office hours, and thanks a lot.